Okay, hi. We're going to talk about addition and subtraction in this chapter. And before we get started, I just want to talk about the learning targets that we'll be focusing on. So we're going to focus on how to write and solve add to, take away, part, whole, and compare problems with addition and subtraction. We're going to use a number line to solve addition and subtraction problems. We're going to apply the associative and commutative properties to solve problems. We're going to explain the addition and subtraction algorithms, and of course we're going to really focus on the explanation. Why do those algorithms work? We're going to talk and describe the how and why to adding fractions. We're going to really build on what we've talked about already about adding fractions. We're going to explain and solve problems with negative numbers, and of course we're going to focus on applying precision, making sense of problems, persevering in solving them, and justifying our reasoning, which are our Common Core standards practices that we're going to focus on. So a lot of times we just think of addition as combining and subtraction as taking away. And so this is going to take us a little bit further because we're going to be thinking of addition as more than just combining and subtraction as more than just taking away. So we all know that a plus b is a sum and a minus b is the difference. So in other words, and you could look at this diagram to help us, if we know that a minus b, if this whole thing minus this section b is c, then we also obviously know that c plus b together will equal a. And so just remember that this relationship between addition and subtraction allows us to solve problems more than just the combining and taking away problems. Okay. Now we're going to talk about some specific types of those addition problems. Remember, the first learning target was about the add to, take away, and part, whole, and the compare problems. So when we have an add to problem, this is an example. If Joe has 12 basketballs, or he had 12 basketballs, and then he received a few more basketballs, and now he has 21, this will help us figure out how many he added to his original 12 basketballs. An example of a takeaway, if John gave 9 apples away and he had 12 left after he gave those 9 away, then that can help us figure out how many he started with. In a compare problem, we can compare how many John and Joe have together. Let's say we're comparing pairs of shoes. So here John has 12 pairs of shoes, and we know that Joe has 9 more. So this diagram will help us compare how many more does Joe have than John. And then the part, whole is simply just if we have 12 oranges and then we add 9 more oranges, how many do we have altogether? So those are just some of the models that we'll be talking about when we talk about addition. Of course, it's much more than just combining. And subtraction, of course, is much more than just taking away. All right, but before we go on, let's talk about the associative property of addition, the commutative property. These are really important properties. The associative property, if we think about it, the word associate is in here in the word associative, and associate means to keep company. So the associative property simply states that a plus b plus c, and this is when you have 3 numbers together, a plus b plus c is the same as a, or is equal to, a plus the quantity b plus c. In other words, a can associate with b or c, and it's still going to be equivalent. The commutative property, if we think about the word commute, it means to change places with. It simply states that a plus b is the same as b plus a, or is equal to b plus a. So in other words, a can commute with b. They can trade places. So just remember that an equation simply means, simply is a statement saying that 2 numbers or expressions are equal. So for example, if we had 7 plus the quantity 6 plus 4, we're saying that the value on this side of the equation on the left is equal to the value on the right, 17. Okay, so let's move on from there. And now we're going to talk about algorithms. So an algorithm is just simply a method or a procedure for calculating. And we have been doing algorithms our entire lives, but maybe we haven't stopped to think about why those algorithms actually work, and that's what we're going to talk about right now. So the addition algorithm is also called the trading or regrouping, or maybe the carrying algorithm, and maybe that's the way that you learned it. So if we take an addition problem like 149 plus 85, simply what we've learned to do is just add 9 and 5, and we get 14, and we write down the 4 and we carry the 1. And then we add 8 and 4 and we get 12 and add 1 more and we get 13. So we write down 3 and carry the 1. And then we add those two 1s together to get 234. We've been doing this algorithm or this procedure for so long that maybe we haven't stopped to think about why it works. So let's talk about that. So what I've done is I've taken 149 and I've broken it down into its expanded form, 100 plus 40 plus 9. And I've done the same with 85. So now I can add my 1s, I can add my 10s, and I can add my 100s separately. So if I add 9 and 5, of course I get 14. I'm going to leave the 4 because I'm going to take that 10, which is my bundle of 10, and I'm going to carry it. So really what I'm carrying when I carry the 1 is really a bundle of 10. So now I have a bundle of 10, a bundle of 40, and a bundle of 80, and when I add those together I get 130, which I know I need to regroup and rebundle because I have 100 there. So let's write down the 30 then for the 10s, and let's carry that bundle of 100. So now I have two bundles of 100, and I add those together and I get 200. So I'm left with two bundles of 100 or 200, three bundles of 10 or 30, four individual 1s or 234. Another algorithm we're going to talk about is the decimal algorithm, and it's why we line up and add our decimals. So we've all learned that when we add decimals, we have to line up that decimal point. But have we really thought about why we have to do that? So let's take this example. 3.7 plus 0.45, or 3 and 7/10 plus 45 hundredths. And when we add by lining up decimals, we have 0 and 5 is 5, 7 and 4 is 11. We write down the 1 and we carry a 1, and then we add 3 and 1 and we get 4. So now we're going to talk about why do we have to line up those decimals. Well, if we think back to our toothpicks and we give 100th, 0.01, the value of one single toothpick, so one individual toothpick is equal to 100th, then that would tell us then a bag of 10 toothpicks is going to have a value of a tenth, and then a bundle of 100 toothpicks will have a value of 1 whole. And so if we don't line up decimals, so this is wrong, so if we don't line up decimals and we just take 3.7 and then we kind of add that in this way, what we're going to do is we're going to add 7 bags of 10 toothpicks to 5 individual toothpicks here. And then over here we would have to add 3 bundles of 100 toothpicks with 4 bags of 10 toothpicks, which is very confusing and not efficient at all. What you would do is you're not really adding parts so that you can't group them together. So when we do line up the decimals, what we're doing is we're lining up like parts. So we're lining up here individual toothpicks, we just have 5. Here we're lining up the 7 bags of 10 toothpicks and the 4 bags of 10 toothpicks. And then here we're lining up our bags of 100 toothpicks. So by lining up like groups, we can then regroup them correctly. All right, so moving on, we're going to talk about adding and subtracting fractions. And when we do that, this will be a little bit of a review since we've already talked about like denominators. So it's just one example we have is 4/15 and 7/15. It's the same as just taking 4 plus 7/15, which is 11/15. And since we have like denominators, we can simply add straight across. And that's because we're adding 15ths to 15ths. So the parts are equal-sized parts. 15ths are equal-sized parts. But if we have non-like denominators, like in this example, 5/6 plus 3/4, then the first thing we have to do is think about finding a common denominator. And so you can see here we're thinking about, okay, the multiples of 6 are 6, 12, and 18. The multiples of 4 are 4, 8, and 12. And you can see that I've underlined 12 here because that's our least common denominator, our least common multiple, which will become our common denominator. So to get then our new fractions, we have 5/6. To get to our common denominator of 12, we have to multiply the numerator and denominator both by 2, so we get 10/12ths, which I've colored in blue here. These are all 12ths. And then I have 3/4 here, and to get to a common denominator of 12, I have to multiply the numerator and denominator by 3 to get 9/12ths. And so I've colored in the additional 9/12ths with green. And so you can see that now we're adding equal-sized parts. Now all pieces are 12ths. Here we were trying to add 6ths and 4ths, but now by having equal-sized parts, we can add them easily, and we end up with a total of 19/12ths. Okay, let's shift a little bit and talk about mental math, because we'll be doing a lot of mental calculations as well. Here's a method of mental math called make a round number method. So if we take this problem, 376 plus 199, we could think of 376 as 1 more than 375. And then we can think of 199 as one less than 200, so we could just round 199 up to 200, since we're compensating for that by thinking of 376 as 375. And so if we just then add 375, which is one less than 376, and 200, which is one more than 199, then we end up with 575. Another method for adding this same problem, round and compensate method, if we think of 376 plus 199 as 376 plus 200, and then just subtract 1 when we're done, then we can just think of 376 plus 200 is 576. It's easy to add those nice round numbers. 576 minus 1 then is 575. All right. And last, but of course not least, we're going to talk about adding and subtracting negative numbers. And this, of course, is a place where students really struggle. There are a lot of misconceptions, and a lot of students struggle, especially when it comes to subtracting negative numbers. So first of all, let's start with the algorithms. This is what we've learned. We've learned that if you take a plus a negative b, that's the same as a minus b. We've also learned that if you take a minus a negative b, it's the same as a plus b. So let's look at why that is. In order to illustrate why, I am going to ask you to think of this black dot as a positive 1 value and this red dot as a negative 1 value. And so here I have 5 plus negative 3, so I have 5 black dots, and I'm adding these 3 red dots. And so if I just combine the 5 black dots and the 3 red dots, and the way I've lined them up shows us that a black and a red together has a value of 0. Positive 1 and negative 1 together has a value of 0. So here I have 3 zeros, and then what I'm left with when I line those all up are 2 positive 1s, or positive 2. So we know that 5 plus negative 3 is the same as 5 then minus 3, which is positive 2. This one's a little trickier to understand, so we have positive 5 minus a negative 3, and we're going to show that that is equal to 5 plus 3. So here are the 5 that I started with, my positive 5, but now I have to take away 3 negatives, but in order to take away 3 negatives, I don't have 3 negatives to take away. So what I'm going to have to do is I'm going to have to add 3 zeros, and that's what I've done here. Zeros add no value to my positive 5 that I start with, but now it allows me to take those 3 zeros away. So by adding those 3 zeros, now I can take the red parts, or the red values away, and I'm left then with positive 8, or 8 black dots. Okay, so now let's look at this same idea on a number line, and I have 4 examples of problems here that I'd like to quickly go through. If we take a positive number plus a negative number, like 5 plus negative 4, we are over here at positive 5. When we add a negative 4, we're going towards 0, towards the negative direction 4. 1, 2, 3, 4, and of course we end up here at positive 1. If we have an example where we have a positive number minus a negative number, here we are at positive 5. We're taking away, think of this as taking away negatives. And if you take away negatives, you're going to become more positive. So here we're taking away negatives, we're becoming more positive by 3. So we start at 5, become more positive by 3, and we end up at positive 8. Here's an example where we have negative 2 as our starting number. So a negative number, subtract a negative number. So here we are at negative 2. We're taking away negatives. So we're already at negative 2. Now we're taking away more negatives. So we're going to become more positive by 5. So negative 2, become more positive by 5, and we end up at positive 3. And then the last one, we start with negative 2. We're taking away 4 positives. So if we're taking away positives, we're going to become more negative. So here we are at negative 2. Now we're going to take away 4 positives. 1, 2, 3, 4. We end up at negative 6. We become more negative by 4. We end up at negative 6. Okay, thanks for listening. And make sure that you keep asking questions if you still have them.